Foundations of Amateur Radio. When you start playing with radio, your first interaction is likely to be voice. It could be SSB, AM, FM, or something more recent like FreeDV or DMR. Your next challenge is likely going to be a digital mode, like Morse Code, Radio Teletype, or my recommendation for your first adventure, WSPR, or Weak Signal Propagation Reporter. I've previously discussed WSPR. Today I would like to look at Radio Teletype, or RTTY. It's a digital mode that allows you to send and receive free-form text. It's a mode with a long and illustrious history, and it's a good next step after WSPR. The way it works is that using an alphabet made up from two tones, information is transmitted one character at a time at a specific speed. The code that describes the alphabet is called the Baudot code, invented by Jean-Maurice-Emile Baudot in 1849. In computing terms, it's a 5-bit alphabet, and in amateur radio it's traditionally sent at 45.45 baud, or bits per second. In case you're wondering, named after the very same man. The two tones have names, a mark and a space, and they're a set distance apart. In amateur radio, they're separated by 170 Hz, but there are plenty of other frequencies and speeds in use. In amateur radio, the standard mark and space frequencies are 2125 Hz and 2295 Hz. In a traditional RTTY-capable radio, the two tones are generated by transmitting a carrier whilst switching the transmitter frequency back and forth, called frequency shift keying, or FSK. Think of it as having a Morse key that sends dits on one frequency and dars on another, having the radio change frequency whilst you're keying. If you use this method to create and decode RTTY by switching between two frequencies, your radio can generally only deal with one RTTY signal at a time, just the one you're sending and just the one that's being received. Receiving is generally achieved by showing some indication on your radio how close you are to the mark and space frequencies that you're trying to receive and decode. Another way to make a RTTY signal is to use sound. If you alternately whistle at 2125 Hz and 2295 Hz, and you do it at 45.45 bits per second, you're also generating RTTY. This technique is called audio frequency shift keying, or AFSK. Think of it as using audio to simulate the shifting of frequency by transmitting two alternating tones. There is a fundamental difference between the two. Before I explain, permit a diversion. It's relevant, I promise. If you've ever spoken on the radio using SSB, you might have noticed that if two stations are transmitting at the same time, you get both signals. With a little practice, you can even understand both. This isn't true for every radio mode. If you use FM, the strongest signal wins, and if you use AM, you get a garbled beep from two stations being on slightly different frequencies. As an aside, this is why aviation uses AM, so any station not transmitting can hear that two stations doubled up. Back to RTTY. If you use audio to generate the two RTTY carriers, rather than shift frequency, you can deal with as many as you can fit into an SSB audio signal. As long as the mark and space for each station are 170 Hz apart, you can have as many stations as you want, overlapping even. As long as your software knows what to do with that, you'll be able to decode each one at the same time, since they're essentially multiple SSB signals being transmitted simultaneously. An added bonus is that you don't have to invest in an SDR to play with this. You can use an analog radio like my FT857D and use software to generate an audio RTTY signal with all the benefits I've just mentioned. The magic is in the software you use to do the decoding. As it happens, I'm about to do a contest using RTTY, and I'll let you know how that goes, using my radio, a computer, and a piece of software called FLDigi. I'll be following in the footsteps of the first ever RTTY contest, held in the last weekend of October in 1953, and organised by the RTTY Society of Southern California. Inasmuch as I'm following the footsteps of Morse Code by SparkGap. Wish me luck. I'm Ono, Victor Kilo 6, Foxtrot Lima, Alpha Bravo.